All right, welcome to day 3 for triangles. Today we are going to be talking about triangles, whether or not they actually exist. Now what we have here is we have a 3-inch, a 4-inch, and an 8-inch. And if I try to make these into a triangle, what you would eventually see is that they do this. They do that. And they have a little gap in them, which cause them to not meet together. The sides do not all meet together. And so this is technically not a triangle because the sides don't close up. With a triangle, we need to not have that gap. Now, as we said in the previous slide, does the triangle close or does it have a gap? It had a gap. And what would you think would need to happen if we had a gap? Let's draw that again. Would one of the sides need to be longer or shorter? What would you think? How could we close that gap? My guess is that it would need to be longer. One of the sides would need to be longer. And the reason I think that, and I'll show you here with my pen, let me just grab another color, is if I took this side and I made it just a little bit longer, and this side made it just a little bit longer, you see there that our gap goes away. So, now that we've answered that question, the last question is to form a triangle. And the answer is no. Some of them just don't work very. I'm trying to put you in my ink color there. It's not cooperating. There we go. Now that you know the answer to that question, this actually has a name. This is called the triangle inequality theorem. And it helps us to understand what the side lengths need to be to form a triangle that is completely closed with no gaps. And what the theorem says is that the sum, and here's that word sum again, that means we're adding, of the lengths of any two sides of the triangle have to be greater than the length of the third side. So if I add up, for example, PQ, this red one, and QR, this blue one, it has to be bigger than the third side, this green one, which is PR. Or if I pick two other ones, like the blue one, QR, and the green one, PR, that has to be bigger than, when we add them together, PQ, which is the red. And lastly, the last pair, PR, the green one, plus PQ, the red one, has to be greater than the third side, QR. So I'll put this little thought bubble here while we walk through this problem. Is it possible? Well, I don't know. Is it possible? Let's see, in your notes, I think it's already worked out. But we're going to work it out. We're going to take two sides, 8 plus 15, and we're going to see if that's bigger than the third side. Then we're going to take two more sides, 15 plus 17, and see if that's bigger than the third side. And then we're going to take 8 and 17 and see if that is bigger than the other third side. So when we add these together, we get 23. Is that bigger than 17? Yes. When we add 15 and 17, we get 32. That's definitely bigger than 8. And 8 plus 17 is 25. That is bigger than 15. So is it possible? The answer is yes. And I believe that's already worked out for you in your notes. Now here's another one where in your notes I have already set them up for you. We have 6, we have 8, we have 14. Is it possible to form a triangle? And notice these key words, to form a triangle. That tells you that we're using the triangle inequality theorem. Remember that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So here what I did was I set up each of the inequalities. Well, 6 plus 8 is 14. Is 14 bigger than itself? No. 8 plus 14 is 22. Is that bigger than 6? Yes, it is. 14 plus 6 is 20. Is that bigger than 8? Yes, it is. So is it possible here? The answer is no, because the 6 and the 8 were not bigger than 14. That means we have a triangle that does something like this. Tiny, tiny, tiny gap. Comes very close to closing, but it doesn't close. So our answer is no. Now, which one failed? Now this is the 6 and the 8 that failed. Was it the one with the two smallest sides, the two bigger sides, or the one with the small and the large? If you think about our three numbers, this is the two that failed. It was the two small sides that failed. So if it's going to fail, that's where it's going to fail. So it's not necessary to do 1, 2, 3 inequalities. We can just try the two smallest sides. Because if that pair is a yes, then the other two pairs are going to be a yes. But if the two smallest sides are a no, then it doesn't matter what happens to the other two.